Hi class, it's Bill Berry here with a video on data types. In the previous videos in this particular section, we talked about inserting, editing, deleting, referential integrity, blah, 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 but now we want to actually switch to talking about the data types that you can use. These will be important when we get to the next topics regarding creating your own tables because we have to specify the data types. So we need to know a little bit more about those. So we're going to explore those in this video. Let's jump down there to that particular part of the slide deck and we will continue. All right, so there is a reference here to the MySQL data type documentation. You can, of course, look up the MySQL stuff. If you don't have a link in the slides, you can always type it in, look it up, and find the full reference for all of this stuff. So you can certainly find the details online for all of this. We're going to use this as our table of contents, and this little hierarchy lets us know what we're going to look at here. We're going to look at all the data types, or at least the main stuff that we need to know for SQL. There's always more interesting corners, but this will cover the basic stuff that we really need most of the time. We're going to look at character data types, and then numeric ones, and date and time, and then some special enumerated types. These are all very useful, so let's jump in and let's first look at the character-based types. If you're storing text, you're going to have certain data types available to you, and let's take a peek at what those are going to be. What you're going to get here, basically, two types. You're going to get the char data type and the varchar data type. The difference is that char always stores the number of characters in parentheses. One thing that you're going to want to pay attention to through this whole lecture is what goes in the parentheses, because that's different for each data type. It's not a consistent meaning of what it even implies to put something inside those parentheses. So pay attention. Here, if you say char and then you give it a certain number of characters, it will always store that many characters. So even if the string happens to be shorter than that, it's still going to take that space and store those characters. So if you know the length of something, if you're storing, let's say, maybe a phone number, or you're storing a social security number, something that you know will always be exactly that length, then char is going to be your best bet. It's going to be a little more efficient in terms of manipulation, so it's a little bit more efficient in those cases. But if you don't know exactly how long something's going to be, if the data is going to vary, then don't use char. Instead, use varchar. The var, of course, means its variable length. The nice thing about that is it stores the actual number of characters that are used plus 1 extra byte to indicate the length of it. So you don't have any particular downside to using this. Again, it could be a tiny bit less efficient in the long run, but in general, this is going to be what you want to do for strings that you don't know the lengths of. So char and varchar. Now, the exact number of bytes, you don't need to memorize this stuff. So for class, you don't need to memorize that. What you just want to know is the basics of using char or varchar depending on what type of string, whether it's going to be variable or not. And remember that it's always going to store the full number of bytes regardless. So that's an overview, really, the two types that you need for characters. Next, we're going to look at integral types, or different kinds of integers. So what we're going to do here is these are going to be numbers without decimal points, and they are going to be stored exactly. So if you are storing things that are going to be used for math, right? If you're going to store things like phone numbers, you won't store them as integers, you'll store them as characters. But things that are going to be stored to be used with math and don't have any decimal points, those will be stored and manipulated exactly. There are a whole bunch of different types that you can use here, and it depends on how big the number needs to be. So you have everything ranging from a tiny int to a big int, and this shows you what the ranges are. And the other thing to note is that you can also add the word unsigned, the keyword, to say, hey, I don't care about negative numbers, so that will move everything to the positive side. So for instance, on a tiny int, instead of it being negative 128 to positive 127, the range is going to be from 0 to 255. So if you don't want negatives, that's a good idea to add unsigned on there so that it will make sure that it won't allow negative numbers, and it gives you a little more range on the positive side. One thing to note here that's interesting is if you happen to look into or see the bool or boolean data type, what happens when you choose that is you're getting tiny int 1. So if you type bool or boolean, you're getting tiny int 1. Now, that's not actually a Boolean at all. That doesn't keep us to true or false like you might think from other languages. So other numbers can get in. So you're getting a tiny int, which means you can put in a number like -13. So sometimes that's a little confusing. So often we don't want to use Boolean, right? That may not be the thing we really want. We'll look at enumerated types later. That might make sense. The other thing to note here is the thing that you put in parentheses for an integral type does not have to do with how much storage. It has to do with what the default display size is. So if you say int4, right, you're still getting an integer size, which means you're getting this huge range. But you're saying, hey, when you go to display it, I think that 4 is generally enough. Well, that's kind of silly. If you really think 4 is enough, probably you don't want integer at all. You probably want something smaller than that. So don't just default to using int because you've seen it commonly. Figure out the integer that makes sense. What type is more efficient for your particular use, figure that out, and then use that instead. So that's a quick overview of integral types. Next, we're going to look at fixed point types. When you're working with math, we're going to see that floating point types have some downsides. Floating point numbers are going to be stored as approximations, which is great for a lot of cases, but particularly when we're talking about money, we're a little uncomfortable with the fact that the money might be stored as an approximation. So we may want to use fixed points, which avoid that problem. Fixed points, in essence, are decimal numbers that SQL takes care of moving the decimal point to make it look like a decimal number. So in essence, you're always calculating in pennies, let's say, if you're using dollars. So have you ever noticed that when you're typing in things on your calculator, even things that you think seem like even pennies, you put in, $3 at 0.99. When you're doing simple addition and math on your calculator, sometimes you'll get something like 0.000001. Well, that's because of floating point math, right? That sometimes can happen. With fixed point math, that's not going to happen because, again, what SQL is going to do is store these things as whole integers, and then it's just going to move the decimal point afterward to where it looks like it's a decimal or a floating point number. So now this one has a very interesting thing about what goes inside the parentheses. The first thing that you're going to see here is how many total digits are you interested in keeping, right? That's the significant, or what's called the precision, right? Let's see, yeah. So that means you're going to say 12 total digits is going to be are going to be maintained. Then 2 of those 12 digits are going to be considered after the decimal point, so that's the scale, right? So the precision first and then the scale. You can use up to 65 here, so you can store very large floating or fixed point numbers here. So you can calculate the size by making this estimation, but again, you don't need to know for our class how many bytes things take. The interesting thing is if you need to store something exactly, but it has a decimal point in it, you might consider fixed point instead of floating point. Now again, a lot of things are fine with floating point. We do a lot of mathematical stuff, a lot of manipulation and fractions and percents and things like that. That's all fine, right? It's only in cases where you really need to keep the precision, which generally is in many business cases about money. So fixed point types are very convenient. Next, we're going to take a quick look at floating point numbers. Okay, floating point numbers, as I mentioned, are stored as approximations. So you will get a couple of, so you will see some rounding errors, and you will see some cases where a lot of digits are displayed when you didn't necessarily intend for it to do. The parentheses here mean something very different, right? They are simply a hint to tell SQL how big a thing you intend to store. If you put up from 0 to 23, it will say, hey, I'm going to make this a floating point number. But if you did anything from 24 to 53, it's going to make it a double precision. In other words, it can be twice as many significant digits. So in essence, as you'll see down here, for maximum portability, actually just don't do this, right? You can do either of these things in MySQL, but really you probably shouldn't. You should probably just use float, and I believe you can also just use double. So if you know you need a huge number of decimal points of precision, then you can use double, otherwise use float, and don't do anything with the parentheses because that's, as I said, that's just a hint anyway, and it's kind of non-standard SQL. So that's a little bit about floating point types, float or double. All right, let's do a look at the date and time functions, right? Date and time data types, rather. So there are a whole bunch of date and time types. You'll see that a lot of business uses require us to manage dates. When are things due? When are things supposed to be shipped? So there are a whole bunch of interesting date and time types. You can use pure dates or just a time, right? So that way you can do hours, minutes, and seconds. You can combine them with a date time or a time stamp. And you can just have just a year. You can either have year parentheses 2 or year parentheses 4. So here, notice this is not part of the data type, right? So don't put anything in parentheses. You just say date, time, date, time. This is just letting you know how many bytes are involved in that, right? But with year, you do put the parentheses. So you'd put year 2, for instance, or you'd put year 4. Now, the thing with these, very useful, as I said, they have a specific format. So when you go to put literals in, as you'll see, we have to be careful with them. There's also some weird things about the date ranges. For instance, here with timestamp, you'll see that the date range is from 1/1/1970 to 2037. I think that's actually 1/1/2037. So that is a weird range, and that leads us to a thing called the 2038 problem, right? That means in the year 2037, you might have a job fixing up SQL because there may be some issues when we switch over and go to 2038. These timestamps are not going to work, so SQL is going to have to make some changes, and there may be some opportunities for some SQL savvy people to make some changes to these databases and scripts. Also, the year has a funny range too. If you use the 4-year format, you're going to get this range. If you do the 2-year one, you're going to get this range, which means, again, somewhere in that year, you might have a job fixing up data from databases that use MySQL. So a couple of the literals, I'm not going to go over these in detail, but you can just see there's different ways to enter date literals. And then there's another slide on time literals, so pause now if you want to look these over. Here's the way that you express time literals, right? So here's a time, and this describes, what this is going to mean. To use a 24-hour military type clock, and that works great. And if you have a combined one, you can put the date and then a space and then the time. So that's just a little bit about using date and time in your SQL data types. All right, last but not least, let's take a look at enumerated types. There are two enumerated types. One we've seen before, and another one is a little bit new to us. So the first is the ENUM, right? So if you want an plain enumerated type, you get to specify all the values that are legal for that column, and the only thing that can be entered in there is one of those legal values, just one. Now the cool thing about an enum is you can specify a whole bunch of them, so you don't need to worry that you're going to run out of space, but also they are very efficient, right? They only use a couple of bytes. That's because they're going to be stored as integer values inside where you can't see it. So that's cool because it's both efficient and it's useful. So remember we talked about the Boolean before, where if you wanted something to be just true or false, but it really turns into a tiny int where you can enter something else. This case will prohibit you from entering anything outside the range, right? It's going to be, if you create an enum that says yes, no, maybe, then it's yes, no, maybe. That's the only thing. So it's very limiting, which is good, and it doesn't take up extra space. Just because you use a long word here doesn't make it take up more room. So that's really good. One thing I would let you know, just as a warning for the future, you might think that this appears to be a space right here between the comma and the apostrophe, and then the same thing here. That's fine, but don't do this when you're working in Workbench, because Workbench has a bug where it doesn't take this. It will reject an enumerated value. So don't type any spaces between the commas and the apostrophes, right? Just smush it right together and everything will be good. All right, now the other one here that we're going to talk about is a set. And a set is an interesting one. It works a lot like an enumerated value, but you can store multiple of those values of them in one particular cell. So whereas enum lets you do one, yes, no, or maybe, with a set you could create something like this where you say, look, mushroom, pepperoni, mushroom, and olives. Then what you can be put into that column could be pepperoni, mushrooms, or you could say olives, pepperoni, and those are both going to be in there. right? So you can put combinations in a set, which is really kind of cool. Now manipulating those gets a little bit more tricky, right? Because you've got to worry about the fact that that your value is not exactly pepperoni, it's actually pepperoni is among the values in there. So that could be a little bit more interesting when it comes to decoding them and writing, especially if you're going to go write any code. But it is interesting that SQL does provide a set as well as an enum. So those are pretty darn cool. All right, so that finishes up our quick look at the different types of data types that you can use in MySQL. These will be very useful, as I said, as we get to creating our own tables and specifying the data types. It's also useful because you'll have an assignment coming up in which you're expected to read some business cases and come up with a data type for each one. When you do that, please be super specific, because you remember each of these has their own oddities about what goes in the parentheses. So you'll need to provide the parentheses and give the values that make sense for your particular context, and choose the data types to be efficient. You don't want to be stingy, right? You don't want to limit something to 128 if you think that in the future it's going to get a little bit bigger. So don't be stingy, but also don't be just plain wasteful. Don't just make everything integers just because it's easy to do. Instead, pick the type of integer that makes good sense for your context and is a little more efficient. So that's our coverage of data types. We will pick up with another video, which should be the last in this series, and we will talk about conversions, where SQL will implicitly or explicitly convert data for you between different data types. Thanks for watching this video.